This is a video lab procedures for graphical analysis. It's a program we use for graphing data in a lot of the experiments we do over the semester, so this is an introduction to it. Go to room SM252, the physics lab. Get on one of the computers there. On the desktop you'll find a folder that says physics. Double click on it. Inside you'll find graphical analysis. Double click on it. Programs here starts up. It's got X and Y columns. X and Y have their traditional meaning, X horizontal, Y vertical at the start at least. Then we'll just put in some data. 0, 1, 2, 3, 4, 5, say, in the X column. And I'll put same thing in the Y column for this example. 1, 2, okay, arrow up, 1. Program loves to graph. You see, as soon as it gets some X and Y's, it starts making a graph. 4, 5. So I have a set of data points. A good policy is to click on the graph at this stage and go to Options, Graph Options. Turn off connecting points because we're going to usually find equations of lines that best fit data when we plug it in like this. I'm going to change the name of X and Y. So I'll double click on the X. I can change that to time, say, common choice, and I'll call it T for a short name, and its units would be S for seconds, which is what we use for time. And I'll go double click on the y-axis and I'll call this velocity. And for a short name I'll call it V. And for units I'll say meters per second, which is a unit of velocity that we'll be using. So now you see the axes have been relabeled. Now I want to find a line that fits this data, an equation, so I'll drag over the points like so. See, I didn't get this first point over here. It's not highlighted. So I can also drag over the points by just going down the table if I couldn't catch this first one. And now I'll find an equation that fits this line. Y equals mx plus b. So I go over to Analyze, Linear Fit. And as expected, this is a line with slope 1 with intercept 0. But it also gives you the units of the slope, meters per second, and meters per second for the y-intercept. And it's showing y equals mx plus b, where it's using the symbols I chose for y and x. You're asked to enter some data and make a graph. Now I'm going to enter some different data. On the second page, you're asked to enter some other data. I'm going to enter 0 for time. I'm going to enter 0. I'll keep it 0, 1, 2, 3, 4, 5. I'm going to call, but I'm going to call it distance. And I'm going to, for a short name, the symbol we use for position in physics is X, and the units we use for position is meters. And we're asked to put time in this column, so in the second example, so I'm going to call this time. Short name T. Units seconds. Done. I'm just making up my own data here, so I'm going to put 0 in for 0 and 1 in for 1. 1.4 I'm going to put in for that unit, and 1.7 I'm going to put in for that, and 2 I'm going to put in for that, and 2.3 I'll put in for that. You should, of course, be putting in the data that you're asked to in the procedure. Now I want to make a distance versus time squared graph, is what they're asking for. So whenever you see something versus something, it's always y versus x or vertical versus horizontal. So I'm going to double click on the vertical axis and choose distance. Now, time squared is the square of this column, and I don't even have such a column. So I'm going to have to produce it. So under data, I'm going to click on data and go to new calculated column. Square the column that has the time numbers in it. So I'm going to call that column time squared. And the short name I'll just leave as CC for calculated column. And the units will be seconds power. Well, to raise to a power, that's shift 6 2. This is seconds raised to the second power. Now the equation that I want to use to calculate this column, I click on the variables tab and I'm going to choose time, and I want to raise that column to the second power. So once again I do shift 6 2 caret 6. Say done, and now we have a new column time squared. And so now I want that on the x horizontal axis because I'm trying to find a plot of distance versus time squared. So I click on it and choose time squared. Notice that the connecting lines are still turned off. So now I want to fit a straight line to this data. So once again I select over all the points. You see they're all highlighted in the data columns, and go to Analyze Linear Fit. And the slope is 0.958 seconds, 0.9587 meters per second squared, and the intercept is 0.081 meters. The data do not fall exactly on a line. That's common due to errors and inconsistencies. So this correlation coefficient tells you how close the points are to a straight line. If they fall exactly on a straight line, this correlation coefficient is 1. If they're like way off, the correlation coefficient can go down to 0. So you have to do a save as, and you can either have your own memory stick, which is a good thing to have, or borrow one from the lab. And go to my computer, find your memory stick here. I'll just save it on the desktop and then make up some name, Jim for instance. Save it, then take the memory stick to the back where a computer is hooked to a printer and you can print your graphs.